I welcome all to the session 37 on current electricity of BSc third semester as prescribed by Karnataka University Dharwad. Today in this session I am going to solve the problems on magnetic field produced by circular coil and the straight conductor. Outcomes of this session are solving problems on magnetic induction due to the current carrying straight conductor and infinitely long straight conductor. Solving problems on magnetic field at a point on the axis of the circular coil and at the center of the circular coil. Some of the important formulas that we come across are as follows. Magnetic induction B due to the current carrying straight conductor is given by B is equivalent to mu naught I divided by 4 pi r into sin phi 1 plus sin phi 2. Magnetic induction B at the point due to an infinitely long straight conductor is given by B is equivalent to mu naught I divided by 2 pi d. Magnetic induction B at a point on the axis of the circular coil is calculated by using the formula B is equivalent to mu naught Ni a square divided by 2 times a square plus x square raised to 3 by 2. Magnetic induction at the center of the circular coil is calculated by using the formula B is equivalent to mu naught Ni a square Ni divided by 2a. Let us solve the first problem. The question is calculate the current flowing through a long straight conductor if it produces a magnetic field of 0.2 into 10 raised to minus 4 Tesla at a distance of 5 centimeter from it. So, the given things are magnetic field B, which is equal to 0.2 into 10 raised to minus 4 Tesla, and the distance from the straight conductor at which you have to find out the magnetic field is 5 centimeter. So D is equivalent to 5 centimeter, which can be written as 0.05 meter. Formula for the magnetic field produced by a long straight conductor is mu naught I divided by 2 pi d. Let us convert this formula for I, which can also be written as I equal to 2 pi dB divided by mu naught. Substituting the values, we get I equal to 2 pi into 0.05 into 0.2 into 10 raised to minus 4 divided by 4 pi into 10 raised to minus 7. Just multiplying and doing the calculations, we get the current I equal to 5 amperes. Let us move on to the second problem. Using Biot-Savart's law, find the magnetic field at the center of the coil in the form of a square of side 20 centimeter and carrying a current of 500 milliampere. So the given things are, here in the diagram you can see P is the center of the square coil ABCD. Here the current flowing is 500 milliampere, which can also be written as 0.5 ampere. Because the coil is in the shape of a square, the sides are equal, so AB equal to BC equal to CD equal to DA, and that is equivalent to 2D, and that 2D is equal to 20 centimeter as given. So D comes to be equivalent to 10 centimeter, that is from point P, the perpendicular which is drawn on CD. So the perpendicular distance from point P onto CD is 0.10 meter. Magnetic field at the point P due to the side CD is given by the formula mu naught I divided by 4 pi D in the bracket sine 45 degree plus sine 45 degree, because theta 1 and theta 2 comes to be equivalent to 45. So sine theta 1 is 45 plus sine theta 2 is 45. So totally it comes to be root 2 mu naught I divided by 4 pi D. Magnetic field at the point P due to all the sides, because the above expression, that is root 2 mu naught I divided by 4 pi D, is the magnetic field produced by the side CD, but a square has 4 sides. So totally altogether we get B is equivalent to 4 into root 2 mu naught I divided by 4 pi D, and that comes to be equivalent to root 2 mu naught I divided by pi D. Here we get B is equivalent to root 2 into 4 into pi into I divided by pi into D. So pi in the numerator and denominator gets cancelled. Substitute the value of I and D. We get the value as 28.284 into 10 raised to minus 7 Tesla. That can also be written as 2.8284 into 10 raised to minus 6 Tesla. Let's go to the third problem, which is for a circular coil. So here a circular coil has a radius of 20 centimeter and the number of turns 50. If a current of 0.4 ampere flows in it, then calculate the magnetic induction at point on the axis of the coil at a distance 0.15 meter from the center and at the center of the coil. So two questions are included here in a single question. You have to find out the magnetic induction at the point on the axis of the coil at a distance 0.15 meter from the center, and also the magnetic induction at the center of the coil. So given R is the radius of the coil and R is equivalent to 20 centimeter, which can be written as 0.2 meter. Number of turns is 50. Current I flowing through the coil is 0.4 ampere. Point on the axis of the coil is at a distance 0.15 meter from the center. So X is equivalent to 0.15 meter. So at the point on the axis of the coil at a distance 0.15 meter from the center, B can be taken as mu naught Ni R square divided by 2 times R square plus X square raised to 3 by 2. Substituting the values, 4 into pi value comes to be 3.142 into 10 raised to minus 7 into N is 50, I is 0.4, R square comes to be equivalent to 0.04 divided by 2 times 0.04 plus 0.0225, the whole bracket raised to 3 by 2. And the calculation comes to be equivalent to 321.740 into 10 raised to minus 7 Tesla, which can also be represented by 3.21 into 10 raised to minus 5 Tesla. At the center of the coil, considering X equal to 0, we get the formula as B is equivalent to mu naught Ni divided by 2R. Substituting the values, 4 into 3.142 into 10 raised to minus 7 into 50 into 0.4 divided by 2 into 0.2. You get the value as 628.4 into 10 raised to minus 7 Tesla, which can also be written as 6.284 into 10 raised to minus 5 Tesla. Let us proceed to the fourth problem. Two similar coils of wire having the radius of 7 cm and 50 turns have a common axis and are 18 cm apart. Find the strength of the magnetic field at a point midway between them and their common axis when the current 0.1 ampere is passed through them. So the given things are I is equivalent to 0.1 ampere, radius A is taken as 0.07 meter, number of turns N is 50, distance X is equivalent to 9 centimeter, that comes to be equivalent to 0.09 meter, because the distance between the two coils on the common axis is 18 centimeter. So exactly at the center the distance comes to be 9 centimeter. So X has to be taken as 0.09 meter. So magnetic field due to the either of the coils at the midpoint on the common axis is B is equivalent to mu naught Ni A square divided by 2 times A square plus X square raised to 3 by 2. Substituting the values, you get 4 into 3.142 into 10 raised to minus 7 into 50 into 0.1 into 0.0049 divided by 2 into 0.0049 plus 0.0081 raised to 3 by 2. The calculation gives you B equivalent to 103.885 into 10 raised to minus 7 Tesla, which can also be written as 1.03885 into 10 raised to minus 5 Tesla. Field due to both the coils at the midpoint between the coils on their common axis is 2B. So multiply the value of B by 2, you get 2 into 1.103885 into 10 raised to minus 5, which comes to be equivalent to 2.0777 into 10 raised to minus 5 Tesla. One more problem, that is a current of 2 ampere is passed through a coil of radius 0.20 meter and number of turns 50. Calculate the magnetic field at the center of the coil and 0.10 meter away from the center. Given mu naught is 4 pi into 10 raised to minus 7 Weber per ampere per meter. So the given things I have noted down. I is equivalent to 2 ampere, radius A is equivalent to 0.20 meter, number of turns N equal to 50, mu naught equal to 4 pi into 10 raised to minus 7 Weber per ampere meter. So here at the center of the coil, B is given by the formula mu naught Ni divided by 2A. Substituting the values, we get 4 into 3.142 into 10 raised to minus 7 into 50 into 2 divided by 2 into 0.20. Calculation comes out to be 3142 into 10 raised to minus 7 Tesla, which can also be expressed as 3.142 into 10 raised to minus 4 Tesla. Magnetic field at 0.10 meter away from the center. The formula here is B equal to mu naught Ni A square divided by 2 times A square plus X square raised to 3 by 2. Substituting the values, 4 into 3.142 into 10 raised to minus 7 into 50 into 2 into 0.04 divided by 2 in the bracket 0.04 plus 0.01 raised to 3 by 2. Calculating, we get 2248.3 into 10 raised to minus 7 Tesla. Same can be expressed as 2.2483 into 10 raised to minus 4 Tesla. These two are the homework problems. So the first problem is a current of 0.5 ampere flows through a coil of radius 0.2 meter and the number of turns 50. Calculate the magnetic field at the point on the axis of the coil at a distance 0.5 meter from the center. Second question is, an infinitely long conductor carries a current of 100 milliampere. Calculate the magnetic field at a distance of 40 centimeter from the conductor. I hope you can do these problems as homework. The references are Electricity and Magnetism by Satyaprakash, S. Chance, Electricity and Magnetism by R. Murugesan. Thank you.